Hello everyone. Myself Dr. Bhavya, working as a research associate at All India Coordinated Research Project on Soil Test Crop Response, University of Agricultural Sciences, Bangalore. And today I will be presenting on development and validation of soil test based fertilizer prescription equations for enhancing yield, uptake, nutrient use efficiency of foxtail millet under dryland condition. As we all know, the food demand is increasing due to the increased growth in the populations. So it's very much important to increase the productivity with the same dose of fertilizers, because it will have the various ill effects on the soil health if the excess amount of fertilizers or the lower dose of fertilizers are being added. Therefore, it is very much important to apply the fertilizer dose by considering the what the nutrient requirement of the crop, and also the contribution of nutrients from various sources like the soil, fertilizers and manure. So there comes the importance of soil test crop response approach. As the name suggests, it takes into the nutrient required by the crop, and the major key features of this approach here, it will consider the, or else will be developing the equations through the multiple regression analysis for a specific yield target of the crop, so which is very unique. So in order to develop the targeted yield equations, it's very much needed to create variation in the soil fertility status within the same field, which will be done through the fertility gradient experiment, as I have mentioned detailed in my paper. That will be done by adopting the inductive methodology, which means we'll be creating the variation in soil fertility status, that is low, medium and the high fertility status within the same field, and will grow the maize crop. So once after developing the fertility gradient, we'll take up the main experiment or the complex experiment, to which we'll be developing the targeted yield equation. So the main gradient experiment will be conducted with fodder maize, and the main experiment will be conducted with foxtail millet, as we are developing equation for foxtail millet. So as I mentioned, the experiment was conducted at Zonal Agricultural Research Station, US Bangalore, and this table represents the initial properties of the experimental site, and all the parameters were congenial, and the texture was sandy loam. So this figure represents the layout plan of the main experiment, where L1 represents the low fertility strips, that it has received half of the dose of fertilizers required for fodder maize, and L2 represents the medium fertility strips, which has received recommended dose of fertilizers for fodder maize, and L3 is the high fertility strips, that is which requires a double dose of fertilizers recommended for fodder maize. So once after putting the layout, we'll add the like what the recommended dose of fertilizers, will sow the maize, and the crop will be harvested at 60 days. As maize is one of the exhaustive crops, the variation in the soil fertility gradient will be created. So after confirming the fertility gradient experiment, we'll take up the main experiment, in the same field where we have taken the fertility gradient. So in order to take up the main experiment, each fertility strips will be again divided into 3 blocks of FIM, wherein F0 represents without application of FIM, F1 is application of recommended dose of FIM, and F2 will be the application of double dose. So overall we'll be having 72 different treatment combinations. So which means that higher the variability created, higher will be our accuracy of the equation. So these will try different levels of nitrogen, phosphorus and potassium fertilizers, and there we'll work out the crop uptake in order to calculate the nutrient requirement, and also the contribution of nutrients from soil, fertilizers and organic manure. After developing the equations, in order to develop the equation, we require the crop uptake and the grain yield. So in this figure we can see that there is a linear correlation between the crop uptake as well as the grain yield. And here we can see the the grain yield and uptake is the higher correlation was noticed with respect to phosphorus, followed by nitrogen and the potassium. Here we did this regression analysis using the SPSS software, and we also did the descriptive statistics to compare the means, range and also the standard deviation, and to know the coefficient of variation among the strip by using the SPSS software. So these are some of the basic parameters that are required to develop the equations. Here from this figure we can see that the nutrient required to produce 1 quintal of the foxtail millet yield is 4.2 kg of nitrogen, 2.87 kg of phosphorus and 4.19 kg of the potassium. So by making use of these basic parameters, we did a multiple regression analysis and we developed these equations also to know what quantity of fertilizer to be added, where Fn, Fp25, Fk2 is the quantity of fertilizers to be added for a particular yield target at a particular soil test values. So if we substitute the value of T, that is what is the target of our desire, by looking into the genetic potentiality of the crop and the soil test value of the soil, we'll get to know the what quantity of fertilizers to be added. So after developing the fertility gradient experiment, we took up the validation trial in order to check whether the equations that we have developed will work or not. So we compared the STCR approach with other approaches of fertilizer recommendations like the general recommended dose and the soil test laboratory approach, which is mostly widely practiced in India, and we had maintained one absolute control. And we added different quantity of nutrients based on that equation. And here we can notice, and here also we did the two-way ANOVA using the Gomez methods with the OPStat software, and we had done the DMRT analysis. And here we can see that the higher yield was registered with respect to STCR approach as well as the uptake when compared to the soil test laboratory approach or the LMH approach. And with respect to the economics, that is the value cost ratio, that was also higher and under the STCR approach compared to the LMH or the what I say general recommended dose. So this represents the nutrient use efficiency. Here also we can notice that is up to STCR 20 quintals per hectare. The use efficiency of nitrogen, phosphorus and potassium is higher for all the STCR treatments, whereas it's very less for the general recommended dose and soil test laboratory approach. So with this, I would like to summarize my topic as the soil test crop response based targeted yield equations, which we have developed for foxtail millet. It's most suitable for zone 5, that is the eastern dry zone of Karnataka, in order to achieve the higher yield when compared to other approaches of fertilizer recommendations like the soil test laboratory approach or the general recommended dose, whatever that is mentioned in our package of practice, and also with that of the farmers practice. And interestingly, the one thing which we have to notice here is that even though the value cost ratio, which is nothing but the economics, is lower under STCR integrated approach, which have received both NPK fertilizers and also the organic manure, that is FIM. The VCR is lesser due to the high cost of FIM, but we have to recommend these treatment for the farming community in order to maintain the like soil sustainability or the soil fertility than recommending the STCR inorganic approach, as the cost of FIM is very higher. So rather than procuring it from other, the farmer can make use of the manure from his waste or the the waste generated from the domestic animals or from the crop residues. He can generate his own compost. He can use that, so that it will reduce the cost of FIM and automatically his economics can be improved. So with this, I would like to thank a science father, international awards on statistical methods for engineering data, for considering us and allowing me to share my research thoughts with everyone. Thank you so much.